Hi guys, so today we're going to go through the rest of the demographic transition model. I'll try to keep it as simple as possible. It's really not super complicated, but the two things you should hopefully remember from our last class are that death rates generally tend to decrease over time rather than increase. If they do anything, they'll go down or stay the same. And the same is true for birth rates, just happening a little bit later. Birth rates tend to go down or stay the same, generally. All the stuff up here is stuff we already went over. This is a chart that follows the path of the death rate and the birth rate over time as countries develop or cities develop, whatever scale of analysis you want to look at, globally, nationally, regionally, whatever. As you get this difference between birth rate and death rate, right in between, of course, if that means you've got more births than you have deaths, that means you've got to have some excess population left over. Otherwise, when birth and death rate is even, you should have no growth, as you see in stage 1 and stage 4. So stage 2 and 3, you end up seeing growth, most of it in stage 2. As the death rate drops, the birth rate is still high. This has led to a pretty severe growth in world population. So historically, most of the world has been in stage 1 forever. This change really only began around the mid to late 1700s for reasons I'll get into in a minute. But the first country to go through this change was most likely the United Kingdom. They developed a lot of things that allowed people to live longer lives. They produced more food thanks to new inventions, had better medicine around the same time. And this led to a decrease in the death rate, but people still had lots of kids. So this chart you see down here is basically global population growth from the year 1000 until projected to 2050. And you can see that for most of human history, our population grew incredibly slowly. Hard to see on this chart, but we reach 1 billion people sometime around 1800. The year I've read is 1807, but you don't need to know that for a test. So if we reached 1 billion people around 1800, and then we got to 7 billion around 2007 or somewhere, that means we added 6 billion people in 200 years, which is insanity. So this is because lots of countries have been dropping their death rate, but still have lots of births. And we're kind of waiting for the birth rate to catch up to the death rate in terms of how low they are. So this led to some very concerning ideas about population. Can't remember if I'll talk about him later, so I'll talk about him now. Thomas Malthus. Thomas Malthus might be a term that you have heard or read about already. Thomas Malthus, you'll read about at some point. You have to know about Malthusian theory for the AP test. Thomas Malthus was, I believe, a British guy who was concerned in the 1800s with how fast the world's population was growing. He said, look, we've gotten to 1 billion or 2 billion or whatever it was. The Earth can't hold much more people than that. Certainly can't hold double that amount. That would be insane. And the reason he said this was because he thought population grows pretty much exponentially, like you see here. It's getting faster and faster and faster. But food production only increases arithmetically. In other words, at like a constant slope. So if this is population growth, our food growth only increases like this as we bring more land under cultivation. So if eventually our food growth line is below the population growth line, we're going to have too many people, not enough food. So I don't know if he proposed solutions to this, but Malthusian theorists then started to come out and say we need to control the population in terms of how many kids people are having, or at least start paying great attention to it. This sort of brings up something I brought up in some classes recently, which is Avengers Endgame, if you saw it. There's all sorts of AP Human Geo memes out there relating to the antagonist in the movie, Thanos, as he essentially argues the same thing as Thomas Malthus. There's too many people, humans are ruining it, the Earth can't sustain it all, so then he goes about planning to kill half the Earth or something like that. I just ruined the movie for you. It's fine, it was boring, I fell asleep, I'm 35. Alright, the eventual thing we'll see is that birth rates, of course, will decrease, but this stunning population growth is still, in some ways, continuing today. So this is the whole chart with a little bit more detail. You can see at the bottom it describes the growth, the most rapid growth occurring in stage 2 as death rates drop precipitously. And they also give these descriptors of the level of technology. So I told you that these stages kind of represent different stages of development for a country. Industry just means factories. So if everyone's farming, people are having lots of kids. And rural societies that have lots of farms, or rural, have high death rates as well, typically, because these are usually more isolated civilizations, not as wealthy, so they don't have as good of access to health care. So death rate and birth rate are about even. But once factories are developed, death rate starts to decrease, partly because some of this industrial innovation includes food growing technology and food producing technology. Like, not all loaves of bread are going to be made in an oven by a person at home anymore. They're going to be made by factories, so they're going to be cranking out cheaper bread, which means more bread for everybody. So that's healthier people, and that decreases the death rate. Plowing machines that will make it cheaper to farm, so that will also decrease the price of food. Factories for slaughtering animals. There's all sorts of great Chicago history related to that. We had the world's largest meatpacking plant for over 100 years. All this will make more food more available more cheaply, and that will decrease the death rate. Eventually, your industries mature to the point where you have not just factories, but a lot of service work, so lawyers, doctors, things like that. And people will eventually realize that they don't need to have that many kids anymore because kids aren't dying like they used to. People don't work on farms as much as they used to. So we should lower the amount of kids we have. It's kind of a personal choice in most cases. So that then leads to a post-industrial world where really very few people are working in factories or farms. A lot of this stuff is done by machines. And instead we have people working in other industries, not just doctors and lawyers, but computer stuff. There's all sorts of things like that. So that leads to more wealthy people who don't want to have lots of kids either. So you can see the general trend here. Stage 1, high birth and death rate. Stage 2, low death rate, but still a high birth rate. Stage 3, death rate is still low, but the birth rate is now starting to decrease. And finally, stage 4, they're both low. So in 2 of these stages, you should be thinking there's not a whole lot of population growth, if any. And that would be, hopefully you can see stage 1 and stage 4 end up having virtually no growth because the birth and death rates even out. So it doesn't matter whether your birth rate in stage 1 is 40, your death rate is also going to be 40. In stage 4, your birth rate may be more like 5, and your death rate would also be 5. So 5 minus 5 is 0, 40 minus 40 is 0, no growth. Whereas in stage 2 and 3, you've got a higher birth rate, lower death rate. So the stages you should see that have growth, of course, are 2 and 3. They've even labeled it natural increase because this is simply the increase that you get naturally from births minus deaths, not migration. And the no-growth stages are 1 and 4. This is a sort of good overview of what the world's birth and death rates are like. These are choropleth maps, although the top one is using many different shades. It uses shades of reds, shades of greens, shades of blues. This one appears to be shades of reddish browns. But you can see where the highest growth would be then generally in the world. If people in sub-Saharan Africa, no surprise, which I've told you have the most kids, they also have the most deaths, let's at least see what the difference is in the highest of the high. So let's look at this country. This is Angola. They seem to have a birth rate of around 45 plus. But they also have a death rate that's the highest according to this chart of 21. That means, of course, 45 births minus 21 deaths at minimum gives us 24 over 1,000 for their increase in people. So they have a growth rate here at some point of 2.4%. Wow. Other countries in the world are kind of the same. This is Afghanistan. They also have high birth rate and high death rate. But notice then, instead of just looking at the poorer countries of the world in sub-Saharan Africa, Let's look at now some of the wealthy countries of the world. The U.S. on this chart, excuse me, seems to have a birth rate of around 40 to 45, if I'm reading it correctly. I'm kind of surprised by that. I'm sorry, I'm looking at the wrong chart. I'm an idiot. Our birth rate, you can see, is 0 to 10, maybe 10 to 15. I think that's 10 to 15. But our death rate is now creeping up around, looks like 7 to 8. So that means our growth rate is a lot slower. So it'd be nice if we had a chart that showed us the natural increase rate for all these, but we've kind of already looked at that anyway. So point is, poor countries have the fastest growth, wealthiest countries have the slowest growth. You're going to see lots of stage 2 countries here and lots of stage 4 countries here, or even what we'll get to today, stage 5 countries. So stage 1, a little bit more detailed history. I told you that this is where all humans have been until about the late 1700s. Stage 1 is where you see the highest birth and death rates. If you haven't yet drawn this chart, you should draw it as we go. We'll go through all 4 stages again, just in more detail. Certainly your note card, it would help if you had a drawing of this chart. You can give an example instead as like, oh, you know, such and such country is in stage 2, but I would draw the chart. It's good practice. You need to know this chart by heart. There's definitely going to be questions about this on the AP test and our unit test. So if you have a high CBR and you subtract a high CDR, what's the result? Hopefully you know by now it's no growth. But why were birth rates so high? We've already talked about this. Lots of people worked on farms, so you need lots of kids to work on your farms. You can't just have 2 parents and 2 kids running a farm. You need lots more people, not just because you need more labor, but also because kids tended to die quite often. Even up until the mid to late 1800s in Chicago, you would see that half the kids would die by the age of 5, which is nuts today. So if you wanted 5 kids, you'd have 10, just to make sure, hopefully, you got the 5 you wanted. The death rates were so high, partly because of lack of good medical care and medical knowledge, but also because food and water was not as readily available as it is today. So people would be drinking polluted water, there wasn't enough food, and this leads to things that we know are still true in some places where people die of very preventable things like diarrhea in sub-Saharan Africa that kills a lot of children under 5. It's one of the major causes of death. So what do they need to survive? Often it's just more food, more water. Doesn't help that they often don't have access to antibiotics and things, but mainly it's food and water. No countries in this stage today. Everyone's advanced past this. However, smaller areas may still be in stage 1. So if we again change this question of scale, instead of looking at the national level, let's look at a more local level. Syria is in the middle of a civil war, has been for the last 6 years. Bet you they still have a pretty high death rate. An area like West Africa that has had Ebola come and go the last few years, possibly in stage 1. So small areas could be, I suppose that's not really local, that may be national or regional. Some areas may still be in stage 1 if some horrible event occurs. Stage 2 then, you start seeing the death rate decrease. So if you have a high birth rate still, but a low death rate, you'd have a high natural increase rate and, of course, a growing population. So add stage 2 to your chart, where you can see you've got the decreasing death rate, but the birth rate is still high. A lot of the countries in the world that are in stage 2 are in sub-Saharan Africa. It's not hard to decrease a death rate. We've done well with that in lots of places of the world. Still, kids in Africa die of common things, and in other parts of the world. But it's better than it used to be. Still has a lot of room for growth, but better than it used to be. But birth rates remain high. This is because people may still be living on farms, still traditionally used to having lots of kids. It's often true that people have about the same amount of kids as their parents had, just because that's what they think is normal or what society thinks is normal. So in some ways it's perpetuating, self-perpetuating, but birth rates remain high just because people often are still in rural situations, and kids also can work to provide money for the parents. Another reason they have a high birth rate is because often these poor folks have less access to birth control, and as I mentioned, it could be customary to have a lot of kids. Women also have very few opportunities outside the home, so One thing we'll talk about in stage 3 is that reason why birth rates decrease in stage 3, one of them is that women will start to work more. I would ask you all in class, and I'm kind of annoyed I don't get to be here today for this because there's so many interesting ways to connect this to class, but ask yourself, if you're a female, what do you want to do when you grow up? Chances are pretty decent you have a plan that resembles something like, well, I want to go to college and I want to go get a job. And that means that you're probably not going to be focusing on having kids as early as 50 years ago or as often. So not uncommon for us to see that even 2 generations before us, that there were lots and lots of kids for among your grandparents' parents. So think about like all 4 of your grandparents. Maybe you don't know how many siblings all 4 of your grandparents had. I don't think I do, but I know that my grandma on one side of my family was one of 8 kids, and then she had 4 kids, but then my mom only had 2 kids, and that's pretty normal today. So at this point, I would have normally asked everyone in class, so who's got the most siblings among any grandparents? So of all 4 of your grandparents, who was the one who had the most siblings? I had a kid last year who told me, I think it was 14. Highly doubt anyone today in this classroom has 13 siblings, right? So even the US a couple generations ago was arguably in stage 2. Still a high birth rate, but a low death rate, relatively speaking. So why has it changed? Well, it's because women have more jobs now, or work more. But if you then flip that and women have very few jobs, well, what do? Well, they do what's traditional for women for thousands of years. They have babies and raise the family. So in many places of the world, this is just what women do. You have kids. So until women have opportunities to get more educated, then they're just going to be having lots and lots of kids. So otherwise they would hopefully get educated and then go get a job. Other things that are worth pointing out then are why the death rate drops. I've mentioned some advances, but the Industrial Revolution and this medical revolution were the big deals. The short summary is that these were inventions that either saved lives, like the medical revolution and creating vaccines and things like that. Cleaner water, germ theory became popular during this time where people realized that diseases pass through dirty water sometimes. But also inventions that result in more food production. That's really what the Industrial Revolution is about. Not just food production inventions, but lots of machinery. The Industrial Revolution, if you want a definition, is the time when machines were invented. Starts in the United Kingdom in the mid-1700s. So again, the Industrial Revolution was the time when machines were invented in the United Kingdom in the mid-1700s. And often these will be used to increase food, like you see there in the bottom right corner, this machine called the seed drill. It is kind of neat. If I had a video of it to show you, I would show you. You can go Google it. There's like 10-second videos that show you how these work, but I'll try and explain it. You can see seeds coming out here in the bottom, and they're inside this hopper. And right here in the bottom of the hopper is a gear that turns, kind of like this one you see here. That gear will have enough space between the teeth of each gear to grab one seed, plop it down here. This looks like a lot of seeds, but the drawing's not entirely accurate. It would take one seed, drop it down, and as this guy pushes this thing more, the gear turns more, and it drops a seed at set intervals. Prior to the invention of the seed drill, the way that you'd farm would be that you'd plow your field, and then you'd have a bag of seeds over your shoulder, and then you would sprinkle some of those seeds in the hole that you plowed. And while this was generally effective, it was also not very efficient because not every seed was getting the same access to water, soil, and sunlight, so not all your plants would grow at the same rate. So kind of a waste of seeds and a waste of effort when some of your plants are not going to grow to full fruition. The seed drill, on the other hand, plants all seeds at set intervals. So every seed gets the right amount of soil, water, and sunlight, grows at the same rate, and so all your seeds are used efficiently, as is your water and soil and sunlight and fertilizer and all that. So the seed drill's main component is its ability to sow a field in the most efficient way possible, get you the most food out of your seeds. This obviously creates more food. More food means cheaper food. So people can eat more, afford more, and they get healthier. This causes lower death rates. There's also more efficient meat packing, so protein becomes more available. Meat used to only be eaten at special occasions like Thanksgiving or Christmas. And once meat packing was made through factories, like Chicago's meatpacking industry, then meat becomes cheaper, and that results in more food for people. The wheat reaper also makes wheat more common. Used to be that you'd have to cut your wheat in a field by hand and do it quickly. This required lots of labor, made wheat more expensive. Instead, if a machine can do it for you, like Chicago's McCormick wheat reaper, then you can plow a whole field in a day or two and have more wheat more cheaply. So again, more food equals more healthy people, which means less deaths. We'll later also see more improvements in medical care, whether it's things like vaccines, antibiotics, but also just better hospitals, better doctors. As medical science improves, they eventually saw how germs spread, but certainly there were better advances in medicine. Penicillin, for example, essentially the first antibiotic, helps us fight diseases. We also finally will see better transportation. We'll see that the steamboat will allow for stuff to be transported farther away more quickly, more easily. Before the steamboat was invented, you could really only bring things down a river, not up a river, upstream. It's very hard to do because you're fighting the current. Once a steamboat is invented, you can travel more easily year-round often than in different directions. And of course also on overseas trips across oceans and things like that. Makes it more safe, but also most importantly faster to transport stuff in all directions. Same thing with the train. Of course, that just applies to land instead of water. There was one last thing, which is water supply. We've already talked about this, but more access to clean water. In Chicago's case, for example, you may know we reversed our river in 1900. It was a huge job. The alternative to this was us simply not putting garbage in our river anymore. We chose to reverse the river. So that, of course, saved all of our lake water, Lake Michigan, where we get all our fresh water from. Prior to that, our river flowed into the lake, polluted our water source, and we would have epidemics of typhoid and cholera almost every year for many years that killed lots of people. Now we have fresh water, at least generally clean, and that means we have less death. So all these advances are huge. I can't underemphasize any of these. They're all amazing. They are still things we benefit from in huge ways today. All right, let's move on. This is taking too long. Stage 3, low CBR, low CDR. How do you get the lower birth rate? So draw that part of your chart, lower birth rate. As you know, population would be growing in this stage. But to enter stage 3, often you'll just need society to choose to have fewer kids. Governments can force people to have fewer kids, like in the one-child policy, but mostly it's people choosing to have fewer children. The TFR, or the total fertility rate, which is the number of kids per woman on average, so you might have a number of like 4 or 7 in a poorer country, or in the US a number more like 2. The TFR will go down often because women will get more opportunities. You can see in this picture there's some women getting educated somewhere in the world, and chances are decent they're going to use that education to then go get a job somewhere, not just sit at home and have kids. The more money women make, the less likely they'll want to have lots of kids. This happens for 2 reasons. First of all, they're busy having a job, so they don't have time to have kids necessarily. Secondly, the more money a woman or a family makes, the more they sort of get used to having a nice lifestyle. And they will start to figure out that having more kids means not only probably less work, so less money, but also less money because you've got to pay for somebody else, a kid. You've probably thought about this. You're incredibly expensive to your parents. You're ruining their life. That may not be totally true, but you're very expensive, which is part of the reason why most of you probably only have 0, 1, or maybe 2 siblings. Last year I had a few kids with 3 or 4 siblings. That's unusual. I would guess most of you are among 2 siblings tops. So that's because partly your parents work, and also they like having money, so they don't want to have lots of kids because they want to have lots of money and a nice retirement and give you a nice life as well. We've already talked about this then. Children are expensive, especially in urban areas, so as more people move to cities, which is the general trend in the world, women will work more and kids will be more expensive. People also worry less about their kids dying young. Part of the reason I told you we used to have lots of kids was because kids would often die before the age of 5. Now kids mostly make it. So why bother having lots of kids if that's actually not the amount you wanted? You used to have extra to make up for the ones that would die. Now you just have less because you can assume they're all going to live. This shows you then the change in birth rates in the world over the last 60 years, not just birth rates, but also death rates. Notice the death rate has continued to drop as health and science have continued to improve, both in poor countries and in developed countries. But you also see this huge drop in birth rate. It's practically dropped in half since 1950. It's almost at 40, and now it's roughly at 20. I'm sure now it's even lower than this, so this is a bit outdated. But the point here is that the natural increase rate, this gap between the birth and the death rate, has dropped to about half of what it was 60 years ago. That means that our population increase globally is no longer speeding up. It's actually starting to slow down. We still see growth, but eventually you can probably guess what the chart might do by 2050 or 2100. Some experts think it will be an even birth and death rate. The world population will no longer grow. It might top out somewhere around 10 billion, maybe 12 billion is what I've heard. That still sounds stunning, but better than thinking that we'll end up with 100 billion or whatever. Similar chart here shows you the TFR, how the birth rate has changed per woman. The TFR, remember, is the number of kids per woman. Since 1950, you can see it used to be around 5, and now it's practically half of that. Right now, I think the world TFR is around 2.4 or something. So pretty amazing. The CIA World Factbook could tell you what the world TFR is, I believe. It's an amazing website. Use it. Stage 4 then is going to be our second to last stage. This is when the birth rate and the death rate are essentially even. So just like in stage 1, you end up seeing that there's no growth. Birth and death rate are even. Birth and death rate are even, so you see no growth. This is also going to have a TFR of around 2.1. This has two names. This exact TFR of 2.1 is sometimes called the replacement rate, but it's also called zero population growth. You may be thinking, well, why don't you have it called zero population growth in stage 1? Because you have the birth and death rates even. I guess the answer to that is that zero population growth has a positive connotation. And you know that if you're in stage 1, having a high death rate, high birth rate, that's not a positive thing. That's bad. So zero population growth really only applies in stage 4 once the TFR has gotten low enough and the birth rate has matched it. So, or rather the death rate has gotten low enough and the birth rate can match it. So this is called the replacement rate, and it's 2.1 for this reason. If you have two parents, this is where I'd usually be drawing on the board. If you have two parents, you have two people. You need two parents, generally, to have a child. So let's imagine two parents who love each other get together and have two kids. Did you grow the population? The short answer is yes. You went from 2 to 4. But you know, eventually, those parents will die. Sorry. That means you'll be left with two people. So the replacement rate is generally 2. Two parents need to have two kids in order to replace the parents once they die. That would result in no population growth or zero population growth. Where's this 0.1 come from then? The short answer is people that don't make it to childbearing age. Or maybe they just choose to never have kids. So let's say that you're born, you're one of 2 kids, and you decide that you don't want to have kids, or maybe you never meet that right person. That's sad. So you just grow up and nobody replaces you. Somebody else has to have more kids to make up for that fact that you didn't have a kid to replace you. So that's where that 0.1 comes from partly. People having more than just 2 kids just to make up for some of those people that don't have a kid or don't make it to childbearing age. Maybe you get out of bed one day and you walk to work and you get hit by a bus. You didn't get to have kids. Sorry about you. So people die still, of course, at various ages before childbearing age for various reasons, but also people just choose not to have kids. So that 0.1 kind of makes up for that group of people that never ends up having kids to replace themselves. Make sense? Hopefully. If it doesn't, rewind it, play it again. Each couple then only will have enough children to replace themselves. I told you that 0.1 accounts for children who do not live long enough to reproduce or choose not to. And many developed countries are here. The US is pretty much here. I forget exactly if we're in stage 4. I think we're actually in stage 5 now. We'll get to stage 5 in a second. For now, see if you can draw this chart from memory. Pause it now. Hit the pause button. Try and draw it. Don't look at your notes. Pause it. Okay, hopefully you've paused it and unpaused it by now. Hopefully your chart looks like this, roughly. You don't need this population growth line. That I think is pretty much implied now that you know what a birth rate and a death rate does when there's a difference. So you don't need the population growth. You should know that the fastest growth is in stage 2. You should definitely know that the death rate is dropping first. These squiggly parts don't have to be squiggly. They could overlap, but it's easier to see them when they're squiggly so you can see a difference. And hopefully you've labeled all these lines. This is a birth rate. This is a death rate. If you drew the population growth line, hopefully you drew population growth. You don't need to know these numbers, but hopefully you've got some numbers on here somewhere, especially these stages, 1, 2, 3, 4. You don't need these names. At the most basic level, you need a y-axis and an x-axis. You need to start your birth rate and death rate near the top up here. Don't give me some line that's near the middle or near the bottom. Start the birth and death rate near the top, and then they should end near the bottom of that y-axis, with your death rate dropping first. That's pretty much all. Y-axis, x-axis, label your birth rate, label your death rate, and then you're done. And your stages. So last thing we'll talk about then is stage 5. Some countries are in this stage. This is where your death rates actually increase. Told you that your death rates pretty much only decrease. You told me that. I agreed with it. But death rates can increase. We've started to see this in some places for some reasons. Like I told you, older people, there's a huge number of them in the US and many other countries from that baby boom about 70 years ago when lots of people were born after World War II for about a 20-year time span, from about 1946 to 1964. And now that huge group of people that were born from that 20-year time period roughly, has made it to the age of their mid-70s. That means they're going to start dying soon. So we're seeing huge numbers of death, I shouldn't say huge, increasing numbers of death in some of these wealthier countries. Doesn't matter how good our medical care is, people are going to die eventually. And of course, going along with that, birth rates continue to decrease for lots of reasons you may be able to figure out. For one, if you have lots of old people, they're not having many kids. That's gross to think about. Let's not even think about it. It would be like rubbing 2 crackers together. But anyway, the birth rate also continues to decrease because you end up having more wealthy people in these countries. And wealthy people don't want to have a lot of kids because they're expensive. So you want to keep living a nice life. That means that eventually, stage 5 has a death rate that's higher than the birth rate. So if you have a higher death rate than your birth rate, what is your population doing? Hopefully you know you'd have a negative natural increase rate. Your population would be decreasing. This is happening in some places, naturally. So a shrinking population. Is this a problem? Yes. We'll talk about why maybe another day. But this is where you'd usually find the most developed nations. The United States, I think, is here. Certainly, pretty much all of Europe is. And I mean all of it. There may be 1 or 2 countries that are not, but pretty much all of Europe. And Japan as well. You should know that. Keep that in mind. Write it down if you didn't. Europe and Japan. This is problematic for lots of reasons, but one is because if you have a decreasing population base or population, you don't have enough tax money. Lots of good examples of this on a smaller scale. Let's say we're talking about Chicago on the south of the west sides where populations have been decreasing. Partly that's because people have been leaving, but we also know there's lots of murders on the south and the west side. People may still be having a lot of kids, but let's take the small scale example. If people start leaving your country, whether it's through migration or through a negative natural increase rate, if your population decreases in any area for any reason, you end up having less people, but you often still have to pay for a lot of the same stuff as a government. So Detroit's a good example. Forget the south and the west side of Chicago. Detroit in the mid-1950s had about 1.5 million people. Today it's got 500,000, but they still have all the same streets. They still all need to be plowed when it snows. They still got all the same street lights, basically. Still got to turn on all the street lights. All these things cost money. and they're not making money as much anymore because there's less taxpayers, less people owning land to pay property taxes, less people working jobs to pay income taxes, less people buying stuff to give sales tax revenue. So how's the government going to end up paying for stuff when there's less money? Well, you can probably guess there's two ways. You can cut back things, which makes your city less desirable, which means even less people are going to come to your city. So that's a problem that's not really going to get a solution. Or you could raise tax money, or raise taxes, rather. This also is a problem because, of course, that also is making your city or state or country or whatever less desirable. So less people are going to come. It makes the problem even worse. So a lot of countries and cities and states have a pretty severe problem on their hands if they have a decreasing population. They got to figure out a way to fix that before things get out of hand, and it can get out of hand within a very short time period, maybe 20 years or something. So Illinois is seeing decreasing populations. It's had decreasing populations for maybe the last 40 years. Chicago's population, like Detroit's, has also dropped in the last 60 years. In the mid-1950s, Chicago's population was 3.5 million. Now we're at 2.7 million and still dropping. So Chicago, for this reason, has had to close schools. I mentioned this in one of my classes about 7-8 years ago. The mayor closed 50-some elementary schools in Chicago because they had low enrollment. These were schools that used to be full. When Chicago's population was bigger, people had more kids. But now schools that have a capacity of 1,000 kids only have 200 kids in them. You still got to pay to heat the whole school, air condition the whole school, light the whole school, provide water to the whole school, but you have less people paying for it. So what do? You shut down the school because it's costing you too much money. Creates other problems, like a less desirable neighborhood, so people don't move there. The problem's even worse. You get the idea. This is a severe issue in many places. So you don't want to have no growth or negative growth. You want to have some growth. This sort of relates then to having an increasing economic base. So this is our full chart. You don't have to know all this for good reasons. Really, all you need, again, is the y-axis, x-axis, death rate, birth rate, and then add stage 5. This is the only thing you should add. The birth rate continues to decrease. The death rate may increase. This is kind of not accurate. The death rate should increase a little bit. Not a lot, but a little bit. So this would be a decrease in the population. Well, here's a real example of this. Here's Sweden's change in birth and death rates since the 1730s. You've got a birth and death rate that are about the same here at the beginning. The death rate drops. Birth rate is still high for quite a while. So stage 1 ends roughly here, where you've got a birth and death rate that are both high, sometimes one higher than the other. But then you see a huge decrease in the death rate around the mid-1800s as they start to get better technology, more food, etc. And attitudes about diseases change a little bit. Birth rate is still high until it starts to drop in the 1900s. And then you finally get to stage 4 around the mid to late 1900s. The US is very similar to this chart. I think that's it for today. So hopefully this made sense. Take the reading quiz. Trying to think if there's anything else to tell you. No, I don't think so. Bye, Felicia.